And if normality is violated, don't go for parametric test. Number one. So a normal distribution, you have to check normality. Other than that, second one is parametric test is for interval or ratio data. It can be non-parametric, can be done for ordinal, interval, or ratio. However, if you have to go for nominal data, we go for categorical type of analysis like chi-square test. For nominal, go for chi-square test. For ordinal, you will go for non-parametric type of test. For ratio or interval variable, go for parametric test. Those parametric tests can be, if they are not, if the data is normal, go for t-test, ANOVA, regression, and so on. If it is not following normality, if the data is not continuous scale, go down. It's safer to go for non-parametric test. Result can be significant. Why? Why we shouldn't take parametric test? Because result will not be as we expect. If you do parametric test for non-parametric type of data, then the result can be significantly affected by outlier, because outlier is affecting our normality. Outlier is affecting our homogeneity. In that case, you will not go for parametric test. You will go for non-parametric test. As I already told, for mean and median also, if there are outlier, don't go for mean, because if there are many outlier, mean will be deviated. Mean will not be exactly what we expect. One person might say 1000, other people are saying 5 mean. Many people are saying 5, giving 5 value. While one person gave 1000 mean, your value will be more than 100, right? Mean value will be more than 100. And if your mean value is more than 100, however, many people are saying 5 mean, in that case, mean is not safe. It is not safer to go for mean because your mean value will be 100. However, many people are saying 5. So outlier will affect parametric test. Outlier will affect mean. So go for median if there are more outliers. So that is the main reason for going for parametric and non-parametric type of test. See the distribution, and usually it also affects the statistical power. Statistical power means the thing that should be correct, as we already mentioned. If power means it has high significance, low error. High correctness, low error. Usually power means that, okay? Power means data is more equal to the actual true value, that is high power. Low power data means it is away from the actual value or deviating away, that is a low power. So power of the test or statistical power will be affected. Now today we will go for this t-test. Now this you have to understand, what is one sample t-test, what is two sample t-test. Many people, they get confused in the beginning on t-test. T-test means you will go for t-test if one variable is continuous and other variable is, or the dependent variable is continuous while the independent variable is grouping or categorical value. So always you will go for t-test if your one variable is continuous, another variable is nominal variable or grouping variable. What that means is, suppose you want to measure the income of male and female. You want to test the income of male and female. Income would be continuous variable. Suppose it might be 100,000, 500,000, million, many hundred million. And what is the grouping variable? Male and female. If you have to compare the income of male and female, you will go for t-test, because there is one continuous variable and there is one grouping variable. Usually you will go for t-test. But sometimes this one sample t-test, you have to understand this, what is one sample. If there is no grouping, you will go for one sample. There is no grouping means there is only one sample. You have to understand. Only one, if there is no grouping, if there is only one continuous variable, no grouping variable, you will go for one sample t-test, because all that data is a one sample. You don't have a group like male and female. If there was the male and female, then you would have two different groups. If there is for whole population, you don't know who are male and who are female. In that case, you will go for one sample because grouping is only one. If you have only group, one sample. Two group, two sample. Suppose if you have to measure the difference in income between, it might be teacher, student, or staff. You want to compare the income of teacher, student, and staff. In that case, how many group are there? 3. In that case, what type of test you will go for? Yes. If there are more than 2 group, you will go for ANOVA. Always understand, number of group will matter either to conduct t-test or ANOVA. Since we are discussing today only on t-test, you have to assume that there are not more than 2 samples or not more than 2 groups. Yes, you can calculate t-test for number greater than 3 groups also. You can calculate t-test, but you have to run different separate t-tests for each and everyone. For example, if you don't calculate ANOVA for student, teacher, and staff, ANOVA will do it once. If you run t-test, what will happen is you have to run for student and teacher. You have to again run for student and staff. You have to run again another test for staff and student. Instead of running 3 different t-tests, we will go for ANOVA. However, t-test can measure the differences, or it will compare the differences between only 2 different groups. Yeah, it can calculate for many groups, but it will be more lengthy, more tedious, while ANOVA can do in one instant. So that is the reason we go for ANOVA and t-test. One sample means you don't have grouping. If there is no grouping, it is one sample. Whole population, only one continuous variable is there. One sample means only one continuous variable, no grouping is there. We will go for one tail test, one sample t-test. While there might be 2 different, if you can do between 2 different things, independent mean just like male, female, they are independent. Male data is separate, female data is separate. In that case, you have 2 groups, but independent. Sometimes things can be dependent. If there are dependent, or if 2 samples are similar, or 2 samples are connected to each other, in that case, you will go for dependent t-test or pair sample t-test. Pair sample t-test means, for example, you are calculating satisfaction before intervention and after intervention. Suppose before giving, or for example, some people went to visit or are coming to visit Acadia National Park. You want to calculate the satisfaction before they start the travel, or before before entering the gate of Acadia National Park, you calculate the satisfaction. And again, you calculate the satisfaction of the same people after coming back from the visit in Acadia. In that case, pre and post you are doing for the same population, same visitor, pre and post. If you are doing that, your sample are dependent, right? Because same people you are comparing pre, but what you are doing pre and post. In that case, you will go for paired sample t-test. Paired means data are paired but of same population. Same person before and after. Same person before and after. If you have to compare between before and after, you will go for paired sample. If those populations are different, male separate, female separate, in that case, you will go for independent sample. Paired means if they are dependent. It means data of same person before and after is the example of paired sample t-test. 2 point of time. After half an hour, you can do it. It means, suppose I want to travel around national park for half an hour. I can calculate satisfaction before entering the park, and after spending half an hour in the park, how much will be the change in my satisfaction. If I want to compare the satisfaction before and after, in that case, I will go for paired sample t-test. And if I'm calculating for male, female, teacher, student, or different groups, in that case, you will go for independent sample This is also called dependent sample t-test, or dependent t-test is a pure sample.